Okay, so the next speaker is Francesco Sauro. The title of his talk, Moving Forward, the Exploration of the Moon's Subsurface, the Lunar Caves Mission Study at the ESA Concurrent Design Facility, CDF. Go ahead, Francesco.
Good morning. This is a talk about a study at the Concurrent Design Facility of the European Space Agency, focused on the exploration of lunar caves. So we know that several pits exist on the moon, especially in the Maria, and this could be really important for accessing the subsurface of the moon and studying, for example, the lava flows, sequences, but especially the subsurface environment for potential utilization in the future. So it's a challenge, it's complicated, and we still do not have a clear idea about the technologies that could be required, which depends also on the objective of this kind of exploration. And the scientific opportunities are several. First of all, from the study of the pit itself, so the study of, for example, of layering of lava flows on the Maria, the evidence of space weathering through paleoregolith, for example, fractures and fragmentation from the regolith to the substrate, and temperature gradients. But also there are several opportunities if there is a cave continuation at the bottom of the pit. It could be a lava tube or other genetic volcanogenic type or related to impact melts, for example. And this could be very interesting for exploration because we do not know anything about these environments. They are completely unknown. We do not know anything about internal morphologies. Of course, about environmental parameters we can model, but we have to confirm hypotheses about their peculiar environment inside. The presence of secondary deposits, impact dust, secondary minerals, and the fact that these could be really pristine environments compared to what we can achieve on the surface in terms of studies of paleo environments on the moon. So there are several challenges. First of all, we cannot really land safely inside the pit or on the rim, so we need to land in a safe area and then move to the pit. We need to address how to do a safe descent into the pit, avoid, for example, rock falling or regolith avalanches triggered by robotic activities. We need to address the power and communication, navigation, and exploration of the cave, and also the fact that these are very peculiar environment where we can have illuminated areas and other in shadow, very peculiar thermal condition through the evolution of the lunar day. So also the European Space Agency in 2019 started to focus on this kind of study, and we had a challenge, a SysNova challenge, open to academia and different consortia. We had several proposals. 5 of them were selected to study innovative system to explore and document this kind of environment. They have been divided in 3 different mission scenarios. One is a scouting geophysical mission where we had a study of a gravimeter and a rover, gravimetry rover by Canadensis, trying to detect the continuation, the cave continuation below the surface, but also smart solution like hoppers developed by the University of Manchester, trying to get a first sight inside the pit itself and try to understand with a quick mission how is the environment within the pit itself for future exploration. The second scenario is already more complete exploration. We have incremental exploration, controlled descent into the pit through a rover platform equipped with a crane. The crane can lower down different cave units, in this case Telelus, which is, we will talk about it later, but it's a robotic sphere developed by the University of Würzburg, and then a quick preliminary exploration of the potential cave below the bottom of the pit. And the first scenario is a more advanced autonomous exploration mission that is being studied by the FKI from Germany, which is more related to autonomous exploration navigation if there is an important cave continuation below the pit. So the concurrent design facility study afterwards has been focused on two of the system, and specifically in the mission type 2. that had the primary objective of exploring, documenting, and performing scientific observation through the controlled descent to the bottom of the lunar pit. And the secondary objective is to try to explore at least a little bit the cave continuation, the map, document, and understand, of course, the environment. The mission duration that we had as an hypothesis is 1 full lunar day, and we want that to be a near real-time mission with a continuous transfer of information to Earth, and really to achieve the most of science and data that we can achieve during this exploration. So this is just an animation. The study was focused on 2 systems. One is this rover with a kind of stabilization system, and a crane, which has been studied by the University of Oviedo, a scissor crane that can extend up to 20 meters from the rim of the pit and can allow the descent of a cave unit down the pit. And the cave unit that we studied is Telelus. It's this robotic sphere, completely sealed. It's an innovative system that allows to have spectral cameras, very, very wide angle spectral cameras, but also laser scanning, and can work both during the controlled descent attached to the cable that provides also power, so can really provide a very high resolution 3D model of the pit, and also can be detached afterwards from the cable, and can use a very peculiar type of locomotion through center of mass movements and some rods that are extended from the sphere itself to overcome obstacles. These are some components. As you can see, there are optical sensors and different lenses that allows spectral studies. Also, the LiDAR is very, very important because allows with different wavelengths to detect, for example, water ice and so on, and of course some environmental sensor for temperature and radiation. So the concurrent design facility was a quite big effort. Usually this is done in prisons, in ESTEC, but we did it online because of COVID restriction. We had 35 specialists from ESA, 23 from the consortia that have been developing the technology. We had more than 60 hours of discussion, and we focus on all the disciplines required to develop a real mission, like environment, landing operation, mission system architecture, robotics, science instruments, power, communication, thermal. And then we had also a full evaluation of the mission feasibility. There will be a report available in the next few months. So this is the final animation. You see the system, the RoboCrane plus Telelus that is descending with a thermal shield and performing a scan of the pit. Thank you very much.
Well, thank you, Francesco, who is not here today once again, but this was a great talk.